Okay, what we learned in our last video, that is if we want to deal with algebraic fractions, first I must do all my factorising. Okay, I must do all my factorising and then I can think about doing some simplifying. Okay, we do all our factorising first. No simplifying, no crossing things out, no dividing things through until you have factorised everything. Okay, if you don't think it can factorise, have another look at it, because normally these questions are set up so that everything factors out pretty nicely. Alright, our first example here, we're going to have x plus 5 over x squared minus 25. Alrighty, let's think about our factorisation technique. Does my numerator have any common factors? No, it does not. They share a common factor of 1, obviously, but that's not a use to us when we're factorising. They're both positive. There's two terms, but there's no squares, so I think I'm just going to leave the numerator as it is. Okay, now the denominator, however, I've got x squared minus 5 squared. Okay, so I've got two terms, both square, and they're subtracting. That's a difference of two squares. So I'll have x minus 5, x plus 5. Now that I've done all my factorising, I'm actually going to put brackets around this. Okay, now what I can do, I have both an x plus 5 and an x plus 5 in the denominator and numerator. That means I'm just dividing them through. Anything over itself is 1. Now what am I left with? I'm left with x minus 5 in the denominator and just 1 in the numerator. So that's where I stop. Okay, to be very clear, this is not equal to x minus 5. You can't just go and rewrite that without a denominator because the denominator is x minus 5. Now, pick some numbers if you'd like. Pick the number 100 and put it into both these expressions and see if it comes out the same. It won't. So pick some numbers and you'll see that it doesn't work to just go rewrite that as equals x minus 5. Of course, if we end up with x minus 5 over 1, that's a different story. That is just x minus 5. But if your numerator is 1, you just rewrite it with a numerator of 1 and your denominator exactly as it appears. As I said, part of this is knowing when to stop. Let's have a look at one last one. I've got x squared minus y squared over y minus x. Okay, well, I know that straight away that the top factors as a difference of two squares, one square minus another, x minus y, x plus y. Okay, now this is almost the same as my denominator, isn't it? But I've got y minus x. Now, x minus y and y minus x are not the same thing. But what I could do is I could look at it and say, what if I take out a negative? If I take out a negative here, I could write that as negative, while this time the x would become positive and the y would become negative. So that actually kind of looks like that, doesn't it? So we end up with negative outside of x minus y. Now these can go. They are just a straight division. Okay, something dividing itself. We're in fully factored form. We are factored. We are in factored form, so we are good to simplify. Now, what I've ended up with is x plus y over minus 1. Well, if I've got a denominator of minus 1, I can just bring that negative sign out here. Means the whole thing's negative, and I end up with minus x plus y. Okay, so that's getting a little bit trickier. That would be probably the hardest example we would have to deal with now. But the main thing is that if you've understood one thing here, before I simplify, I must factorize. I must get everything factored. Okay, I hope this has helped.